Hello guys, welcome again to another lecture. In this lecture, we're gonna explore a very important, library, a tool that we can use in our assembly language programs to extend the assembly capabilities or our programming capabilities actually. So, the basic motivation for this library, which is called Irvine Library, is that there is no standard libraries for assembly language programming, and there are many, many features that is very difficult to implement in assembly, very difficult. Like for example, printing on a screen, this is a very common feature in all programming languages that you can print any message, for example, on the screen of your computer, or what's called the standard output. But it's you can do that in assembly, but it's very complicated. So that's why Irvine library, importance appears. So Irvine library, as far as I know, is implemented by a guy called Irvine. His last name is Irvine. He has, a book on assembly language, and he implemented many functions and just to provide this, this library as a library basically, and combine all these functions in a library, and you can just download it very easily and include in your Visual Studio. And of course, one of them, is printing on a screen. Just one line, you can write just one word basically, or I'm sorry, two words, call, write int, for example, or call, write message, whatever, you can print something on the screen. Okay, although if you do this yourself, it will be very complicated and very time consuming because you're going to write a lot of code lines. But just if you include this library in your Visual Studio, you can do that in just by writing just two words, basically, two keywords, basically. So Irvine library functions. So each function, perform or some specific job, and some has some requirement for its inputs and its outputs actually. Of course, we need to learn how each function how each function works before we use it. Okay, and you can learn about all the functions through this link. If you open this link, you're going to find all the functions in Irvine library, and you can just open each one of them and learn how it works. And you can download the library itself from that link. And we're going to do both in our labs, okay, this week's lab. So let's take some examples from, the Irvine library. The first one, and the most intuitive one is dump registers. Dump registers. So as the name suggests, this, function, when you call it, it will dump on the screen all the values of, the registers in your processor, basically. Here is a very, simple program of just one line. So the main code here, is called dump register, and you notice here that each function in Irvine library is preceded by the call command, or call keyword basically. So when you call dump register, as you see here, this will open a console window. This is called the console window. It's it's basically a screen window like a DOS window, for example, and in this window, all the registers will values will appear, like for example EAX here, EBX as well, and all of them, and even the famous or most important flag register bits, like for example the carry flag, the sign flag, the zero flag, overflow flag, auxiliary flag, and parity flag. Okay, it's the current values. Good. Another important function is write binary. So if you have a number, or in decimal, for example, or for example in hexadecimal, and you want to automatically show its binary, content or conversion, you just need to put this number into EX, and its requirement here is that this number should be in EX, and then call the function called write binary, right? This is basically an acronym for write binary, write bin. So in that case here, EX has 15, and 15 we know it's 4 ones. Of course, EX is 32 bits, so here is 32 bits, and all of them are zeros except the first 4 bits. Write character, write char. Write char is another cool, function in Irvine Library, in which if you have the ASCII code for some character, and you wanna, print what is the corresponding character of that ASCII code, you can just put this character into AL. And why AL? Because AL is 8 bits, and you know that the ASCII codes are 7 bits. It's even less than 8 bits. Okay. And then you call write char here. So write char will look at EX or AL, of course, the first 8 bits, and write on the screen the corresponding, character. And the corresponding character for 38 is ampersand, the ampersand. Write decimal. So again, if you have a value in hexadecimal, for example, and you want to know its corresponding decimal value, like the conversion, again put this value into AX and call write decimal. And in that case here you have 0f. We know that f is 15, and that's why we see 15 on the screen here, written on the screen. Write integer. Write integer here, will just print out the current content of EX, whatever it is. So for example here, if we move minus 43 into EX and call write int, then this will, show us here minus 43. One may say why we didn't use decimal, because minus 43 it's of course decimal. So when we convert it to decimal, it should be also decimal. The problem is that if you do write decimal here, like the previous slide, it will show some number, because the minus, remember the minus is represented with the 2's complement. So it will deal with the content of X as a just unsigned number and show whatever it is, which is of course will be wrong. So that's why we use integer. So integer here is dealing with signed number. So you don't worry about if you have a sign in your number, it will appear as signed number. But write decimal, unfortunately, is dealing with unsigned number. So remember this. The carriage flow, or the carriage return, basically. It's like basically, printing a new line on the screen. It's like hitting the enter button on the keyboard. Okay. So for example, let's assume you have 2 write integer statements. And if you call them, behind each other without the call carriage return, it will appear like this: plus 42 minus 42, which is of course weird. So that's why here we differentiate between both printing by calling, the carriage return. So the carriage return is like, hitting enter basically. So the first write int will be on a line, and the second write int, which is minus 43, will be on a separate line. Write string, and the name suggests everything. So if you have a string and you want to print this string on the screen, we learned, we learned that's already, by the way. It will be, we will deal with the string as an array, and we make a loop, and we go into this loop until we found the last character. But here, with just one line, go write string, it will just print everything on the screen. And one observation here, or one important note, is that you must put, comma 0 at the end of the string when you define the string. Okay. So basically, here we're defining an array. Each location in that array is 1 byte. So H will be a byte, E will be a byte, L, each one is a byte, and so on. Okay. And the end is will be 0. This 0 just to know, to show the similar, that's the end of this array. Readend. So also it's a common feature in all programming languages that you have, a function in which you can read from the screen. So for example, in C++, you have cout to print something on the screen, and you have cin, which takes input from the user or from the screen. So the user, entering a character, for example, it will appear on the screen, and cin will just read this character into the program. Okay, so readend is exactly the same, like cin, cin in C++. So let's assume that we wanna, we have a program. This program, reads a number from, the user, and print again this number. Okay, so we're gonna use some of the, the stuff that we learned. So basically, we're gonna first show, a message on the screen. This message is enter number. So the user, when he or she reads this message, he knows that he should enter a number, and followed by, the enter key, and that's the stopping, notation. So readend will stop, or will read what the user has inputted to the screen once the user hits the enter key on the keyboard. Okay. So we're gonna show first the enter number message. The user will know he should enter, a number. He puts, for example, 50. Then we're gonna show this, message you entered, and then followed by, the 50. So we're gonna have two strings, prompt string and result string. So first, and one thing here that I forgot to mention is that when you write a string, you must put, the address of the first location into EDX register, EDX. So in the beginning, we're gonna put, the address of the first location of the prompt into string into EDX. Then we call write string, so that string will appear, which is enter number. Then we call readend. So now the user should, enter something, and the computer will wait for us. So the user, for example, enters 50 here. Then we're gonna show now the you entered. So we're gonna move the first location address of the result, string into EDX again, and we call write string. And remember, write string will write, the string in which the first location is stored in EDX. So it will write you entered. Then we're gonna call write end. And remember, write int will write what's into AX in the screen. So basically, when you read int, this will store what the user inputs into AX. And remember, we learned already that write in will write on the screen what's in EX. Okay, so we don't, although EX doesn't appear here at all in the program, but it's implicitly used. It's used by readend when the user when the user hit enter. So readend will take the 50 and put it in AX, and writeInt will use again AX to take its value basically and put on the screen. Okay, guys, that was basically an introduction for the Irvine library functions, and we're gonna continue in the lecture with other functions as well. So thanks for now, and thanks for watching, and see you in the next video. Bye.